Where does all the energy and matter come from to create the new universes? What would happen if the Milky Way galaxy stopped rotating?
I'm glad I'd never got through that many in my whole life.
To whomsoever it may concern. All right, what do you think? What do you think this is? Science Friday?
Cosmic queries. Galactic gumbo.
Yeah, I don't know.
This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. This is going to be a Cosmic Queries grab bag. And whenever you hear that, you know who's sitting next to me. Chuck Nice.
Hey, that's right. What's up, Neil?
All right.
Grab bag, baby.
Grab bag, baby.
That's right. Used to be, I liked it when we were Galactic Gumbo.
Okay.
You know? I don't know why because, that's I
never know what the hell you're saying.
That's what it should be. Yeah, I love it. Anyway.
Plus, gumbo kind of left menus. You don't see it much anymore.
You don't see gumbo a lot. I'm going to New Orleans next week. And
well, give me a full report.
Yeah.
Because the first time I had it, it's like, why are there 100 things in my soup?
That's gumbo in a nutshell.
All right. So, what you got?
This is Jordan Senerth. Greetings, Dr. Tyson and unnamed co-host, hopefully Lord Nice.
All right.
All right. Jordan from Boston here. I understand an object's mass to be the sum of its invariant mass,
yes,
rest energy,
yes,
and its momentum.
Yes.
A photon, because it has no mass, must then be pure movement, momentum,
sure,
or energy.
Mm-hmm.
Okay. Here's my question. Oh, okay, good. You have one. He says, thought he was just showing off.
Yeah, that's a little bit of that too, but that's fine.
But
nothing wrong with showing off if you got it.
He says,
if you got it, flaunt it.
Yeah. He says, are the gluon and the graviton then pure something else energy?
Well, so the graviton is the particle version of a gravitational wave.
Right.
It's not been detected. It's presumed to exist if you look at it from a quantum gravity worldview.
Okay.
Okay. And the gluon is the mediating force of baryons and quarks within the nucleus of the atom. So gluons hold the quarks together.
Right.
And
glue.
It's how you can get two protons that close to each. Think about it. They have the same charge.
Right.
Like charges, what?
They should be popping off.
Exactly. Like charges repel, and so that is repelling from the electromagnetic force.
Right.
But if you get them close enough, the strong nuclear force, which is brought to you by the gluon, the strong nuclear force is stronger than their urge to separate.
Okay.
And it keeps them together. So what we're asking here is can we think about the graviton and the gluon in the way we think of as a photon? See, think as a photon is pure energy, whereas the graviton is not.
Right.
That would be a particle.
It'd be a particle.
Yeah, and same with the gluon.
Right.
So we're stuck with the on suffix to the word, making you think that they would be the same thing.
Right.
But regardless, there's a mass equivalent of the graviton and the gluon.
Right.
You can always, even if it's just energy, you can figure out how much mass equivalent that is using what equation?
E equals mc squared.
Thank you. Other than the gluon and the graviton being particles and the photon being energy,
right?
I don't know what other distinctions to make there. All right, what else you got?
All right, this is Chuck Betlatch or Betlock. He says, hello, StarTalk team. I understand that anything with a mass also has gravity. Can a small mass, such as a CO2 molecule, orbit a larger mass, such as a person? So he has localized gravity down to, like, objects.
Yeah, the answer is yes.
Okay.
However, many particles have their own, when they're in a gas, they have their own motion commensurate with the temperature of that gas.
Right.
All right. So for many gases, their motion is so high that they would just escape the system. That's why the moon has no gas to speak of.
Right.
Okay?
I mean, except on Taco Tuesdays. Sorry. I had to do it. I am so sorry. I know that was terrible.
That was terrible.
So bad.
Terrible. Terrible.
Terrible.
So, but if you don't want to just isolate a molecule,
right,
then the answer is yes, it could orbit you.
Right.
You just give it the right speed, at the right distance, in the right direction, and there you have it.
And you have that one molecule
that's it. By the way, all the CO2 molecules in the air, they're not quite orbiting the Earth, but they're attached to Earth, so Earth drags them with it.
Right.
As it turns.
Right.
So, and then it's not escaping because there's gravity. Gravity is strong enough to hold the atmosphere. So that's not orbiting the Earth, but it's carrying it with us.
Right.
You know, if you like your molecules and you want to keep them, that's another way to do it.
Right. Okay. There you go, Chuck. Way to go. Great name. This is Larry Infante. And Larry says, hello, Dr. Tyson and all. One thing that has bugged me about some sci-fi movies is their use of Earth's time. For example, they may use minutes, hours, and days saying, we'll be back to claim your planet in 24 hours. These apparently are some very hostile aliens.
As they all
that
are.
have come and...
As aliens want to be.
And they have given us an ultimatum for some reason, even though they have traveled across this galaxy and they are able
They could totally kick our ass that instant.
That instant. Why do they have to give us 24 hours? I don't know. But clearly they're just like, you have 24 hours to surrender and we'll be back. And he says, if you had to create a system of time with no reference to a planet orbiting a star, how would you do that? Lorenzo Infante from San Antonio, Texas.
Great question. So, keep in mind, we evolved on a planet that has a 24-hour day-night cycle.
Right.
Since that is our biorhythms, who cares if you're on Earth or near the sun if you want to respect your biorhythms? Right. So go on a journey to another star, keep the 24-hour day.
That's what. We all have internal cellular clocks that are our circadian rhythm. So whether or not you're around the time or not, you're going to your body's going to know 24 hours.
Your body's going to know, and because we evolved in that state.
Right.
Now, from studies that I've seen a few decades ago, I haven't seen them duplicated, but I was intrigued.
All right.
They took people, put them underground.
Okay.
Living underground.
Chuds.
You can't see day, night. They took all the clocks away. So they're just living there.
Wow.
And so
I think they call that a casino.
No windows, no clocks.
No clocks. Underground.
So, again, this is a study from many decades ago. Okay. But they found that people naturally fell into a rhythm that was 25 or 26 hours long.
Makes sense.
Not 24.
Not 24.
And then I thought about that, and I said, that's why everybody's groggy when they wake up.
Right. We need an extra hour.
An extra 2 hours.
Right.
We're forcing ourselves into 24 hours when maybe the body is saying, give me I need a 26-hour day. So they didn't have to touch their snooze bar.
Mm-hmm. Got me working 26/7.
That doesn't sound...
It doesn't sound good at all.
26. So I'd be perfectly happy keeping my 60-second minute, 60-minute hour, 24-hour day.
Right.
I don't care about weeks or months or years because I'm counting days.
Okay.
Because we sleep on day cycles. So that's what matters to me, no matter how long my voyage is.
Well, what about the aliens knowing the fact that we're on a 24-hour clock?
Oh, because if they said, we'll be back in 47 gloops, that's not helpful. So
they would have done a little research.
They're doing a little research. Use a time unit that we know and care about.
Right.
And by the way, we don't think about time in tenths of a second or hundredths of a second or billionths of a second.
Unless you run track.
And you're Usain Bolt.
Right.
Okay. But generally, that's not a thing.
Right.
So a second is, by the way, your heart beats about once a second.
That's right. Yeah. I mean, if you're really healthy.
Yeah, if you're healthy.
Yeah, if you're healthy, you get about 60, 62
yeah,
beats,
60
64 beats
per
a minute.
Right.
Yeah.
So these feel kind of natural to me. And if the alien wants to communicate with us,
Right.
it better damn straight use my units.
Right. Yeah, exactly. Yeah, and by the way,
if they land in America, they better know inches and feet and miles too.
let me tell you something. Wouldn't that be something? They come here and they're just like, "We'll be back, and we're going to make sure that in 50 kilometers you're going." And we'd be like, "What is this guy talking about?" Dude, where are you from?
Nope, that's lame. Ready? Do you harbor questions about the universe? Some long-held bit of cosmic curiosity lingering within you? Or questions about anything at all? You can become a Patreon supporter of StarTalk. You have access to our exclusive question line on our website. Those are where we draw our questions for our cosmic friends.
Some of the most extreme objects in the universe.
StarTalk is a work in progress where we, every month, come up with some new way, some new idea, some new understanding of how to bring the universe down to Earth. We could not do that without your support. Thank you. And as always, keep looking up.
Mike says, "Hello, Neil. Hello, Lord Nice. Long-time listener, new to Patreon."
Nice.
Well,
Welcome.
thanks a lot, Mike.
Well, let me say it right. Welcome to the universe.
Nice.
Say that right.
He says, "My question is about the likelihood of 2001: A Space Odyssey, in particular, the new form of life observed in the dual star system, as well as the fabricated central hub for the wormholes."
He mentioned 2001.
Yes.
But I think he's referring to scenes in 2010, which was Arthur C. Clarke's sequel to 2001.
Gotcha.
If my memory serves. I saw that long ago,
Right.
On first run when it came out, but that's my memory of it.
Yeah.
Yeah. By the way, I'm cool with if you're alien, you're more advanced. I'm cool with all that.
Yeah.
What would we look like to our own species from 100 years ago?
Exactly.
What would we look like today? Oh my gosh! I mean, if we are that amazing in the future compared to our own species and our own planet, imagine aliens. So I'm not going to second guess their double star system and their wormhole factory. Right. Fine.
I mean, there are binary star systems.
Yes.
Right.
Yes. That's not a weird
And
thing.
what about planets around binary
They're
star
a little
systems?
unstable because their gravitational allegiance is challenged every time they try to make an orbit. Who am I closest to? Who am I far away from? Who am I?
Maybe you this time. Maybe you this time.
So you need a really big orbit so that the two stars are seen as one field of gravity.
Gotcha.
Right? Because only when you get really close do you
would you have the perturbations?
Exactly.
Right.
Exactly.
Okay.
Exactly. If I remember in 2010, Europa was where the intelligent aliens lived. One of Jupiter's moons.
Okay, now that's a little too. I'm sorry. First, you're going to put the intelligence on the white planet.
on Europe. Yeah, so they're asking the plausibility of it. Yeah, I mean, the double star system, sure.
Yep.
Aliens that have control over that, give it to them.
Why not?
Why not? Yeah.
All right. This is Alex Million. He says, "Hey, what's up, lads? Alex from Northeast England here. Simple question for you all, just for fun. Do you agree with pineapple on pizza? Inquiring minds would like to know. I love your show and have fun." I'm a big no, but guess what? I've never had it, so I can't say I'm a no.
Generally, if you do it, it's kind of Hawaiian style, and it would be pineapple with a ham thing, right. And because we know pineapple goes with ham. Okay.
Absolutely.
But I, as a native New Yorker, you know where this is. This is not going to end well.
Here's where you going. Where you going here with the pineapple on the pizza? What's your problem? Huh?
I'm eating over here.
I'm eating over here. I ought to slap you one. Yeah. Mook, what's your... Anyway.
I'm crossing the street here. I'm eating here, over here. So, for me, pineapple belongs in a pina colada.
Ooh, yeah.
And not in a pizza.
There you go.
Of all the things I would do with the pineapple,
right?
Pizza is not on that list.
Not on the list.
Yeah.
Okay, I got you.
Okay.
I love it.
That's my opinion.
Yeah, you know what? I'm gonna have to try it now because I'm cringed by the whole thought of it, but I've actually never put slice to mouth to say that sucks.
Well, plus it's also hot fruit at that point.
I know, that's so
That's
nasty.
what I'm saying.
Except for blueberry pie or peach cobbler.
That's different. Yeah,
That's a whole
that's
other
different.
hot fruit thing, but that's
right.
okay. All right, here we go. This is Hugh Cayley. Hugh says, hello, Dr. Tyson, Lord and Nice. Hugh Cayley here from Richmond, California. During the most of my life, if you read a layman's book on cosmology, it would confidently state that if you somehow moved in a straight line long enough, you end up where you started. Is this still the case now that the universe is thought to be flat? Thanks.
So that what he's remembering was not that statement given confidently. It was that statement given as one of the alternatives of what the shape of the universe would do for you.
Okay.
So I don't believe that that was stated confidently. We didn't know, but we had the formulas to tell us what the universe would look like depending on if it was saddle-shaped, spherical, or flat. It turns out the universe is flat.
Okay.
So no, you don't come back to where you are.
You don't come back.
You don't come back. It's forever.
You just keep going.
Oh, by the way, and if it weren't flat and if it was positively curved, then the coming back happens because the universe would recollapse on itself.
Right.
And everything's back in the same place at the same time. So that's how you end up back where you are. It's that future space-time
Right.
trajectory that brings you back. Time would be in a loop in the case with the universe recollapsing.
Right.
All right. But how about just we are here? If we're in a spherical universe, you walk straight, eventually you come right back to where you started. And that's no different from walking on Earth.
Right. Same difference here.
Same difference.
That's the wait.
And when people say, where's the edge of the universe in that scenario, I'd say it has no edge. It's got to have an edge. It has no edge. Okay, where's the edge of Earth's surface? It has no edge. Okay.
Right.
Because it has, well, you can think of the edge as going up.
That's a different story.
As Carl Sagan said,
Right.
Earth's surface is the shoreline of the cosmic ocean. It's a three-dimensional shoreline.
Here you go. Wait for the tsunami. It's going to be something else. Woof. Well, okay. And this is Joe Boone. And Joe says, Kia ora, Dr. Tyson.
Oh.
I am from New Zealand, and I have a question related to your explanation of time dilation. Specifically, that time does not exist at the speed of light. In science fiction, there are often cryopods for interstellar travel, but often those spacecraft, like the Nostromo from Alien, travel faster than light. Therefore, shouldn't there be no travel time from the point of view of the crew? The cryopod is only necessary for Ripley in the shuttle at the end of the film because it was just drifting in space. In reality, wouldn't the people of Earth need cryopods if they ever wanted to see a crew again in their lifetime? I'd love to have your take. Apologies if I've misunderstood time dilation.
What's the person's name again?
This is Joe Boone.
Joe, you understand it perfectly.
Yes.
And everything you said is 100% accurate.
Correct.
If you are traveling the speed of light, you don't need cryopods.
Because there is no time. Well, there is time, just not from your frame of reference.
Yeah, you get there as soon as you left.
As soon as you left.
Right.
As a matter of fact, you wouldn't know that. You wouldn't know what happened.
You don't need the cryopods.
Right.
So it's a correct.
Just like a photon is born and dies the moment that it hits whatever
Correct.
it's hitting.
Correct. And ideally, my detector at my telescope.
Right.
And not the buttocks of
And
someone.
not the black behind of Chuck Nice laying on the beach. Like, ooh, look at these photons.
There's a photon you go through 30,000 years from the beginning of the galaxy.
And then you just
the
hear
center
it
of the
coming
galaxy.
straight for my butt. Like, no! No, where's the telescope? Where's Neo? Oh! Why doesn't this guy shave? Anyway.
Shave your butt? What? I don't even want to. No, stop there.
Okay,
Stop.
I'll shut up.
Yeah, he's completely correct.
All right.
I have nothing to add or subtract from that entire
He did
account.
he did a great
Did
job.
a great job.
Yeah. By the way, the reason you need a cryopod is because for storytelling purposes.
Yeah.
One, something always goes wrong with somebody's cryopod.
That is how science fiction stories work.
Right.
You go into space and something goes wrong.
Something goes wrong. So you need the cryopod as a mechanism for storytelling.
To kill people.
Right, exactly.
To kill innocent people.
So anyway.
One other thing. There's, as far as we know, you cannot travel the speed of light if you have mass.
Right.
So that would put a kibosh on that whole idea.
Thing. Right, yeah.
But otherwise, yeah. Well, in all fairness to that,
go ahead.
You can go 99.9999% the speed of light, and it's essentially not aged, but you still wouldn't need the cryopods.
Right.
Actually.
Yeah. So instead of getting there instantly, you get there just like, oh man, I didn't even get a chance to get an in-flight meal.
Correct.
Damn.
That's right.
Yeah. All right. Elaine Berdu says this. Hello, my name is Elaine Berdu from Montreal. Just a quick question. If a spoonful of neutron star material can weigh as much as Mount Everest,
easily, yeah.
Would Mount Everest come rushing out of the spoon if we brought it to Earth very quickly? Come on, lady, this ain't Jumanji.
Jumanji.
This ain't Jumanji. It's densely packed. It's not a sea monkey. It's not a freaking sea monkey.
It's not a chia pet.
Nah, I'm joking.
Let me go to Neutron Star City. Let's just open out the spoon.
Yeah, that's so funny.
So here's the way to think about that.
Okay.
The answer is no.
Right.
As described. But here's the way to think about it. The energy it would take to scale a mountain on Earth is the same as the energy it would take to step up onto a sheet of paper on a neutron star.
Wow. That is rough.
That's rough.
Yeah.
That's rough. And so neutron star flattens everything.
Right.
So we think neutron stars might be the best spheres in the universe.
Right.
Because whatever's there just got flattened.
Got flattened out.
And she wants the thing to pop back up as a mountain when it comes here. But once you're flat, you don't go back.
That's it. Well, look at that. Once you go flat, you never come back, baby. Emery says this. Dr. Tyson and Lord Nice. Emery from Florida here. I remember in high school, we would take 1.5 volt dry cell battery and hook the wires up to 2 inverted test tubes in boiling water connecting hydrogen and oxygen. Using the collection principle, wouldn't it be much more efficient collecting the hydrogen and oxygen off the cavitation of a propeller? Almost free on ocean cargo ships.
Oh, 2 things.
Go ahead.
First,
Right.
I did not know. Is that true? I'm not denying it. I just never heard that you could, what the word is, dissociate. So hydrogen and oxygen are very tightly bound. So that's why water just go anywhere. It's coming out of the sky and the ground.
Right.
Water is water.
Right.
Okay? To break that molecule apart requires a huge investment of energy.
A lot of energy.
Do you know the evidence that it requires a lot of energy?
My stove?
No.
No.
You bring them back together.
Oh, and they create a lot of energy.
They create a lot of energy.
Yes.
That's all the energy it took you to pull them apart.
Right.
That's why when we go to the moon and find water, we don't say, oh, that's just rocket fuel, which it is. But you have to put the energy in it to separate them to get that energy out as rocket fuel.
Wow.
It's not just like oil sitting in the ground for you.
Right.
Okay. So I did not know if that's the case, that it would be at the tip of the fastest moving part of the propeller blade, that there's high enough energy there to break apart the oxygen and hydrogen. If there is, that's kind of cool.
It is.
And yeah, why not put a collection mechanism there?
Right.
But you're really after the hydrogen because oxygen is, you get that for free anywhere in the atmosphere.
Right.
So if it does that I'm intrigued by that. And you're right. There's propellers going across the ocean all the time.
All the time.
Yeah.
Yeah.
So I can't comment on whether that's a real thing. But if it is a real thing, yes, do it for sure.
Cool.
But keep in mind it requires energy.
Right.
to make that happen.
So that's what I'm saying. Yeah, yeah.
But the propeller's already expending that
is
energy.
the energy that they're expending.
Right. Mm-hmm.
It's a great thought experiment. But right now, shipping companies are reinvesting in sales
Wow.
to
help out the propeller?
to help reduce the amount of fuel that they use.
Wow.
And there's a company, I believe it's called Cargill or something like that. They're making these giant sails that are controlled by computers, and it cuts like the fuel consumption of a tanker like by 50%.
So what's it getting its energy from?
It's a sail.
No, people don't think about it.
Yeah.
But sails getting its energy from wind.
the wind.
Wind gets its energy from the unequal heating of Earth's surface.
Right.
So air moves to where it's hot or not hot,
Right.
and where the pressure is.
So it's really solar power.
It's solar power.
Yeah.
That's what I was getting at here.
Oh, okay, gotcha.
Yeah.
Everything's solar power, and yeah,
Almost everything.
almost everything's solar. And but here's the kicker.
What?
Can't use that for energy. How we gonna have a solar power? Like no, you gotta burn something, man. Come on. Anyway, just it's so infuriating.
Drill, baby, drill.
I know you drill.
All right.
Drill, baby, drill. Yeah, that's it. Anyway, that's what I told somebody. I said this last week to somebody when I was Florida. I was down in Florida, and I said, so that big thing up there, it's 93 million miles away. It takes 8 minutes at the speed of light for the light to actually get here, and yet you can lay on that beach and it will burn your ass. But yeah, you're saying that it's not effective because they were saying like solar power doesn't work. It's too expensive and it's not effective.
It's called brainwashing.
You know what? There you go.
It's really that simple.
I really didn't think of it until you just said that, and I'm like, why did you argue with that idiot? Like, why would you argue with that dude? Yeah.
If an argument lasts more than 5 minutes, then both sides are wrong.
And so I was right, because you know what? I said that to him, and he was like, no, it doesn't work when he said that. And I was like, okay. That was the end of the argument.
Yeah.
I was like, okay.
Yeah.
Yeah. All right. There we go. This is Tom Isaac. And Tom says, hi, I have a question about the many worlds theory of quantum physics. The question is, if every quantum measurement causes the universe to split into multiple universes, where does all the energy and matter come from to create the new universes? It just materializes? Out of what?
Yeah, I can't comment philosophically on this.
Okay.
But I can comment from practical terms.
All right.
The many worlds hypothesis is an attempt to make rational sense of something that's otherwise completely irrational.
Mm-hmm.
It's to understand experiments in quantum physics. You invent a whole universe so that the other result goes into the other universe. That's the result that you didn't see, but might have seen, but didn't see. And okay, but I don't know what I can add or subtract from that. Because if you're going to create a whole universe, where does it get the energy from? I don't know.
Right.
Maybe they've thought about it. I don't know the answer.
Okay.
And I'm perfectly happy to say we forged our sensibilities, our senses and sensibilities on the plains of the Serengeti trying to not get eaten by lions. And there's nothing about our primate brain that prepares us for quantum physics. So when quantum physics doesn't make sense, I recite the opening line of my book.
The universe is under no obligation to make sense to you.
Thank you.
There you go.
Thank you.
Yep. All right.
And by saying there's many worlds, you're forcing it to make sense to you, but it brings out other issues as well that go unresolved.
All right.
Yeah.
So this is Mile Milkovsky or Millie Milkovsky. Or
they didn't give you helping.
Or some. That's weird. Okay.
Millet sounds good. I like that.
Millet, maybe we'll say. All right. So he says, hi, Neil and Chuck. My name is Mile. No. Oh, no. He gave it to me. He gave it to me phonetically, and I still can't say it.
Oh, that's bad.
God.
Oh, that's bad. Chuck,
I know.
you can't pronounce the word nor the phonetic spelling of the word?
No, I cannot. Mile. Okay, Mile, I'm going to go with that. From Macedonia, Balkan, Europe. Okay. He says, Neil, in your last book, To Infinity and Beyond, in the chapter To the Edge, do you mean that when we talk about the expanding universe, we are referring to the observable universe expanding?
Yes.
I thought that when everyone talks about the universe expanding, it's about the total universe expanding.
It's also that.
Please explain what I'm doing wrong.
No, you're not doing anything wrong.
No, you got it right on both accounts.
Both counts. The expansion universe is the entire universe.
Right.
But when we speak about it in practical terms and what your telescope can see, and we see, quote, the edge of the universe with your telescope, that's the observable universe.
Right.
But I myself as well, have been a little sloppy there, distinguishing the universe from the observed universe. And I get a little sloppy. I ask forgiveness there. The whole thing expands.
Right.
But the part that's expanding that matters to us is within our horizon.
Right.
All right. Mm-hmm.
Okay. I hope, Mile, you're right and you're right. There you go.
That's it.
You're right and you're right. That's all there is to it.
Hey, StarTalk fans. I don't know if you know this, but the audio version of the podcast actually posts a week in advance of the video version. And you can get that in Spotify and Apple Podcast and most other podcast outlets that are out there. Multiple ways to ingest all that is cosmic on StarTalk.
This is Trisha Lynch, who says, hi, Dr. Tyson and Lord Nice. This is Trisha Lynch from Beaverton, Oregon. What would happen if the Milky Way galaxy stopped rotating, both suddenly or gradually?
Wow.
Thank you for everything that you do.
I think I drove by Beaverton, Oregon
Oh, really?
last year.
Oh, okay.
Or earlier this year.
Oh, is it that kind of place? You just got to drive by.
No.
Oh, my God. What's that over there?
No, I was
That's
visiting,
Beaverton, Oregon?
visiting Ashland, Oregon.
Oh, okay.
And I think Beaverton is somewhere in the area there.
Okay.
And I went to see the Shakespeare Festival there in Ashland, Oregon.
Oh, wow. Look at that.
I'm just saying.
And, I guess Central Park was not good enough for
Central
you.
Park, New York.
I guess. You left Manhattan to go to Beaverton, Oregon, because that's where the good Shakespeare is. Yeah, forget Shakespeare in the park. Yeah, all right.
So, now I forgot the question. Now, what was it?
So, basically, she's saying, if we stopped our
stop
little
the
spiral
rotation.
galaxy from spiraling, either very quickly or slow down to a stop, what would happen?
Oh, that's a good one.
Okay.
Okay. The fact that we are rotating is the only thing preventing us from falling into the central black hole.
Wow. So at the center of our galaxy is a black hole.
Yes. And if we stopped rotating,
Right.
it means we're no longer orbiting
That black hole.
the black hole. And so we just descend.
Damn.
Everything in the galaxy would fall into the black hole.
Wow.
Everything. That's right.
That's
By the way, it's no different from saying, here's the space station. Let's just stop it in its orbit.
Right.
What's it going to happen? What's going to happen?
It's
It's going to fall right out
right
of the
to
sky.
the Earth, right.
Yep.
yes. Exactly.
So be glad we have orbits,
Right.
even around black holes.
So, oh wow. That's a tenet of physics.
Yes, it is.
Spin stabilizes. So
Well, no, it's a different spin
No,
stabilizing.
I know that's a physics here on Earth, but I'm saying it's
No,
the same
no. Spin stabilizing is a different phenomenon.
altogether.
Oh, yes. Football is spin
That's what I'm
stabilized.
saying. That's a spin stabilized,
Yeah.
but this spin is not stabilizing us?
It's
What I'm doing is interpolating.
okay. It's preventing us from
affixing
falling
one to
into the
other.
middle. It's
Okay.
preventing that.
It's just preventing.
Our sideways motion. That's correct.
okay.
And you can say, oh, look how perfectly the galaxy
so wait a
is.
minute. See, you said it differently now, and that's the difference. It's not spin. It's sideways motion.
Well, it's orbiting. It's
Right.
an orbit.
That's what an orbit is.
Yeah,
Sideways motion.
Correct.
Right.
Correct.
So, yeah. So we're falling around a black hole right
And
now.
by the way, any matter that was there that didn't have the proper speed,
Right.
it fell in already.
Right. So we're actually falling. We just have sideways motion that keeps us from going in.
Correct.
There you go. I got you.
You
now.
got it.
I got you. Okay, cool. Great
And
question.
if it
Trisha.
slowly came to a stop,
Right.
then slowly the orbits would just sink in
Right.
until it came to a stop, and then everything would just
And everybody
rapidly
will
fall.
roll. Right.
Yeah.
So, damn. Slow. Yeah. So one's a slow death. There you go. Monopoly World wants to know this. To whomsoever it may concern.
Ooh.
All right, what do you think? What do you think this is? Science Friday?
No.
Like, I just put this question out to everybody, and whoever picks it up, please answer it. You know,
To
I don't
whom
care
it may
if it's
concern.
Bill Nye, Science Friday, Brian Green, just to whom.
All right.
All right. He says, please explain the Casimir Force. I saw Harold Sonny White on Joe Rogan talk about it, but I need your version.
Well, thank you. Thank you.
Okay.
So let me give what I think is my best account of that.
Okay.
I don't think I'm missing anything, but I might.
Okay.
Okay.
I'm going to be Joe Rogan now.
Okay.
Okay, here you go. Go ahead.
So you have two parallel plates of conducting material.
Okay.
Metal,
All right.
let's say.
And what's metal?
Metal conducts electricity.
Okay. All right.
One of the properties of metal is that it conducts electricity, but there's other properties that define it to the chemist.
Okay, I only have 3 hours here, so let's talk about that.
So
All right, go ahead.
two plates, very flat metal plates,
Right.
and there's air in between them.
Okay.
So why don't I evacuate the air so that there's nothing going on,
Nothing between them at all.
nothing between them, okay? There's no vibrations from the molecule. Okay, so there they are. Now there's a vacuum between them. And I just slowly bring them closer and closer together. There is a distance within which they will feel an attractive force and pull together
And pull together.
as a Casimir Force. Correct.
Right.
I think this is correct. The interpretation is it is so close that the particles on either side of the vacuum, we're now so close to each other that the distance between them rivals the wavelength of the particles in the parallel plates to begin with.
Okay. The distance between them
Between the two plates.
rivals the wavelength
Right.
of the particles
That comprise the
that
plates.
comprise. Oh, okay.
So you're now contained within a wavelength of the subatomic material.
Oh, that's freaking amazing.
Yeah, it's freaking right. The fact that someone would even do that experiment and find that that's the result,
right.
that's crazy.
That is incredible.
So that's the Casimir effect, and it's a purely quantum mechanical phenomenon. It doesn't have an analog in classical physics.
Right.
Yeah.
That is really, I got to tell you, some of the freakiest crap right now as I'm thinking about right now. That is really freaky, man, because there is nothing between them.
Yes.
But what you're saying is the wavelength of the particle now becomes like a pressure.
Yes.
And that pressure of the wavelength of the particles itself, even though there's nothing between them,
Right.
creates this force that mimics magnetic attraction,
Yes.
but it's not magnetic attraction. It's not. It's
Correct.
the two coming together.
Now
That's
I'm just thinking about this out loud.
freaking crazy.
No, it is. It is.
I love it.
If I got something wrong in that explanation, it might not be the particles on the plates. It could be the wavelength of the virtual particles that exist in the vacuum.
In the vacuum itself.
that's between them.
Well, yeah.
But it's a
It
similar
wouldn't make a
phenomenon.
difference. It's the same principle
It's
no matter
principle.
what.
It'd be the same principle.
Whether you got that part right or not, it doesn't make a
okay.
difference. We're talking about the phenomena itself.
Yes.
That's amazing.
Yeah, it's just a whole new phenomenon.
Gosh.
Yeah, I think he won a Nobel Prize. So that's a testament to people asking questions and doing experiments.
It really is.
Yeah.
Wow. How have I not heard about the damn Casimir?
You didn't know about the Casimir effect?
effect? But I mean, it's brilliant. What a brilliant experiment. I love it.
So that's the Casimir effect.
Wow, that's pretty cool, man.
Yeah. All right.
Pretty
All
damn
right, what's
cool.
next up?
All right, this is Scott
Time for
W.
one or two more questions.
All right, Scott W. Peterson says this. Hey, gang, Scott from generic suburban Denver. Very nice, buddy. Very nice. On a recent episode, Dr. Tyson corrected the movie idea about the density of objects in the asteroid belt.
Yes.
We just go through, don't have any constantly twists and turns to avoid things. Related, if the asteroid belt ever got it together, how large an object would it be? In other words, would we have another planet, or would Neil end up putting it in the dustbin like Pluto?
People still haven't gotten over Pluto.
No, they never.
All right, so a couple of things.
All right.
If you look at the distances between the planets, Mercury, Venus, Earth, Mars, Jupiter, there's a huge gap between Mars and Jupiter.
Okay.
And people are saying, there should be a planet there.
Right.
Let's look.
Yeah.
This is in the 1700s. Let's look. There's got to be a planet there. And we discovered a planet there. We discovered planet Ceres. And then Pallas and Vesta and Juno. The first 4 planets discovered in the asteroid belt. If you look up in 1805 textbooks for how many planets there were in the solar system, it was Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Pallas, Vesta, Juno, and the 4th one. I forgot what. So they would count as planets until we said, wait a minute, they're all in the same place, and but they're kind of different, and they're really small. They're kind of rocky. They're not planets. They're asteroids. They're star-like. Asteroid.
Oh.
Star-like.
Star-like.
Because they're tiny dots of light, just the way stars are, except they have nothing to do with stars. People presume there was a planet there. They found these fragments, and they were very excited about that. However, if you take all those fragments and glue them together into one object, you get something about 5% the size of the moon.
Well, that ain't a planet. That's all I'm saying.
Yeah.
That ain't even.
That was
a
never
moon.
a planet.
That ain't even a moon. You kidding me?
It was never a planet.
Right.
Right.
So
It's an excellent question.
It's a great question. So it's basically just it's trash. It's just leftover trash from the creation of our solar system.
Yes.
That's all.
Yes, that's what debris.
Debris.
Yeah.
Okay. Excellent. All right. This is Rye Guy. And Rye Guy says, greetings, Dr. Tyson and Lord Nice. Rye Guy here from Arlington, Virginia. Is it possible that space and time existed separately to one another prior to the Big Bang, and the Big Bang is the result of separate dimensions violently merging? Are there any signs we could theoretically look for to confirm that as our origin story? Is there anything that exists that would explicitly disprove that possibility?
So this which possibility again?
The possibility that space and time itself were separate. The Big Bang itself fused them, and now they're inexorably tied.
But you have never noticed a time unless you were at a place.
Right.
And you've never been at a place without having noticed a time.
Right.
So why should we believe they were ever separate? What would it even mean
For them to be separate.
to be separate? It's not clear.
Well, I think what he's getting at, because we've talked about this before, in a higher dimension, we're free from the constraints of time in this dimension.
Yes.
So what he's saying is it possible that this is some kind of derivative of that higher dimension where we're free from time,
Okay.
and now we're bound by time?
Yeah. So I can't imagine a higher dimension where you can move freely in the time coordinate. That's what you're talking about.
Yes.
Yeah. And so that's a good fact if we lived in a place such as that.
Right.
I got to quote Einstein here.
Go ahead.
Time is defined to make motion look simple.
Damn. Einstein was gangsta. Time was defined to
make motion look simple.
That is so profoundly simplistic that it's scary.
Yeah. Yeah. And the scary part is that it might be correct.
Yeah.
So I don't know what it would mean to have a universe without time.
Right.
How do you have events that follow other events?
Right.
Is it just frozen there forever? I don't know.
Interesting. You're right.
Right.
Right. Because the motion itself connotes time.
Correct. And so, yeah, I'm not convinced.
Right. This is Jaden Peters, who says, Greetings from Utah. Jaden here. Longtime listener, my question is a simple one, but simultaneously complex. We'll be the judge of that, Jaden. All right. He says, what advice would you give to a physics major currently in college, particularly considering today's political climate and the defunding of scientific programs? I have great apprehension of completing my degree in astrophysics. Thank you so much. Wow. I was joking when I said that, but that is a really serious question that Jaden puts forth for you.
Yeah. So
Damn.
I'll give a cop-out answer, then I'll give a real answer.
All
My
right.
cop-out answer is, and this too shall pass.
Okay. Right. Science is going to be here no matter what.
That's true.
When we went through, there were dark ages.
You can say, I don't want to fund science, but somebody will.
Somebody's going to do it.
Somebody's going to.
That's right.
Somebody's going to play the tune,
All right.
and you have to dance to that tune.
So
Because whether or not it is we, there are other countries in the world that value science on a level that makes our investments look bad. So, yeah. So, but anyhow, I would say physics is foundational to. There is no understanding of biology without chemistry, and there's no understanding of chemistry without physics. I have chemistry books from the 1800s. You open them up, it's like, well, add 3 parts pitch blend and 2 parts sulfur, and you get. Next page, add 1 part hydrogen. What's up? There's no. It's kitchen recipes for chemistry. Not until we understood the periodic table of elements. Why is it periodic? Why do elements in a column make the same kinds of molecules? What's going on? It's all explained with physics. All of it. And don't judge any future of anything based on what's going on in the present when you're still in school. Yeah, if it was 80 years ago, you say, oh, what's the good industry will be in 20 years? I'll tell you that.
Plastics, son. Plastics.
Yeah. I mean, back then, the things didn't move as fast. So your whole career could be planned out and you'd know exactly what you'd be working on. Today, I mean, oh my gosh.
Right.
I think we're good there.
Yeah, man. That's great advice. Science is going to be here no matter what. So
Well, especially physics.
and physics. So stick with physics
Just stick with it.
and go for it.
Then, as a physicist, you understand matter, motion, and energy. And there's nothing going on in the world that doesn't tap at least one of those 3.
There you go.
And most of it involves it all.
Nice way to end it. Yeah.
Yeah. All right. Another installment. Galactic Gumbo.
Yeah, that don't move. Matter and emotion. That's right.
Are there any high-pitched Galactic Gumbo voices?
There can't be.
There can't be.
There's nobody in New Orleans who's walking around going, no. Gotta be like this. That's what I'm saying. Don't know on that kid. You're showing guarantee.
All right. That's all the time we have, Chuck.
Oh, man, that was good, though. That was a fun one. That was fun.
That was fun. I'm glad I'd never got through that many in my whole life.
Yeah, that's
okay.
Yeah.
All right. This has been another installment of StarTalk, Cosmic Queries, Grab Bag Edition, or according to Chuck, Galactic Gumbo. Always good to have you, man.
Always a pleasure.
All right. Neil deGrasse Tyson, for StarTalk, as always, bidding you to keep looking up.
Thank you.